Okay, welcome to the aquaculture lecture where we define aquaculture and we talk about why it's relevant to fisheries management. And here is the answer why it's relevant. So we currently have a 7.5 billion. In 2000 it was 7.1 billion. And in 2030, that's only 15 years from now, not even 15 years from now, we're expected to have 8.3 billion people. And how do we feed them? Right now we're only catching about 90 million tons, or we are catching about 90 million tons, and that hasn't changed for the last few years, even though fishing effort is certainly not dropping off. So if we expect to have a demand between 150 and 180 million tons, where's that extra 65 million tons of seafood going to be? Where is it going to come from in order to feed all these people? So the question then is, can we just farm our way out of this? Can we just grow enough fish to supply that demand, fish and other things? Well, in science, if we're going to talk about any issue, then we need to very clearly define our terms. And so we need to define what aquaculture is. Now, this definition from the FAO will be good enough for you for your for the course and for thinking about aquaculture during this course and for next year. And the good thing about this definition is that it reminds you that it's not just about salmon and snapper and kingfish. It's about all sorts of different aquatic organisms, plants, animals, including things like amphibians and crustaceans, mollusks, shellfish, all of this stuff. So it's very wide it's a very wide and diverse group of organisms that are cultured. And it's not new. It's been around for thousands of years. Okay, so there were texts, Chinese texts from 4,000 years ago that were written about how to culture carp. So we can assume that the culturing was going on for quite a long time before that, so this aquaculture has been around for a long, long time. But we're refining it on industrial scale these days. In 2011, according to the FAO, there were 59 million tons produced by aquaculture of all sorts of organisms, and that equates to 16.5% of the total marine fisheries. And unfortunately, that hasn't really risen very much in the last few years. So 16.5% of total marine fisheries. All right, we've done the easy stuff, but without turning the waikato into introducing species like tilapia into our ecosystem. Then we're probably, we have to start working out aquaculture production increases with a little more foresight into environmental impacts. But if you expand that to the inland and freshwater fisheries, 40% of the world's fisheries production, or 2 out of every 5 fish that hits the table, are cultured. Now, there's really no reason to enhance the production of a fishery or a stock unless you're going to reap some benefit. So, but if you're going to do aquaculture, then that means that you're intervening in some part of the life cycle of that organism in order to bolster the stock, in order to enhance the production. And if you are just harvesting what's naturally there, then that's commercial fishing. Some examples of enhancing the production would be feeding. Okay, so you supply food to organisms. that are either wild organisms or ones that you've contained in a farm, and those are your stock. Okay, protection from predators. So this would be a common occurrence around salmon farms where there are seals. They try to get in and have a go at those big fat, slow-moving, contained big salmon that would be a nice meal. And breeding and genetics. So if you are going to grow these two fish that are depicted in this image, which one do you think, as a farm manager, you'd like to grow? So they may have grown to the same size. Maybe that's a 2-year-old fish. Both of them will be 2-year-old fishes. One will be have grown to almost twice the weight, or probably even twice the weight of the first one. And you see small and big people. So it's just picking the ones that are fast growing and selecting those for making your new generation, and then you can get some greatly enhanced production that way. Okay, so as we said before, there's really no reason for anybody to enhance a stock unless they get some benefit out of it, and nobody's going to put their own money into a stock enhancement, a aquaculturing endeavor of any kind, without being able to get the benefit from it. So it usually implies that you're able to exclude other people from harvesting that stock, and that of course means that you have some sort of ownership. A couple of definitions for aquaculture. Extensive is where you intervene in that organism's life cycle for only part of it. And seeded scallops, which we'll go over in class, that's a prime example where the scallops are only grown for a few months and then they're captured from the wild, grown for a few months, and then reseeded into the wild. And then an intensive aquaculture is where you manage that organism throughout its entire life cycle. So you have the brood stock, you settle the larvae, you get them to breed, you settle the larvae, and then you grow them all the way till harvest. And that is an intensive aquaculture type. Polyculture is where you have several different organisms and you're trying to mimic the natural environment. So we have primary producers and secondary consumers, and these things complement each other. One fertilizes the other. Oxygen and then is oxygen and food is what's the output of the primary producers, and nutrients in the form of nitrogen, phosphorus, other wastes as the output from the consumers. So you've got watercress and rice as primary producers, and then tilapia and carp would be the consumers. And for example, with mussels and sea cucumbers, where you have two consumers, the sea cucumbers will gain some benefit out of consuming the waste that winds up on the seafloor from the mussels. Alright, so review. We've talked about the definition of aquaculture, some extensive and intensive. We've looked at population growth and why aquaculture is relevant to fisheries management, and we've talked about corporate ownership. Okay, thank you.